Okay, congruent figures is what we're going to be talking about today. And first we have some vocabulary. First vocabulary is congruent figures. Two figures are congruent when they have exactly the same size and shape. They may be sitting on the paper differently, they may be facing different directions, they may be rotated, but they're going to have the same size and the same shape. Corresponding parts are matching parts of congruent figures, and there are both corresponding sides and corresponding angles. So for example number 1, it says identify congruent parts. First by writing a congruent statement for the triangles, and then identify all the pairs of congruent corresponding parts. So what I would like for you to notice here is that first of all, we have a right angle on the first triangle and a right angle on the second triangle. So I'm going to say triangle A and triangle F, because A corresponds with F. And then if I come over here and I notice that this is a single notch and angle B, and angle G has a single notch, so B corresponds with G. And then angle C on my first triangle has a double notch, and angle H on my other triangle has a double notch, so C corresponds with H. My congruent statement then would be, in this exact order, that triangle ABC is congruent to triangle FGH. Now, just the way we went and named corresponding angles, I can then make those statements that angle A is congruent to angle F, that angle B is congruent to angle G, and that angle C is congruent to angle H. That would be naming all the corresponding congruent angles. And to do the same thing with the sides, you just have to be careful that you go in the correct order. So let me list them first, and then I'll go back through it. Segment AB, or side AB, is congruent to side FG. Side BC is congruent and corresponds to side GH, and side AC is congruent and corresponds to side FH. The order in which you list these points is important. So on my first one, for example, I want to say AB, and I'm starting at the right angle and I'm ending at the single notch. So on the other one, I'm going to start at the right angle and end at the single notch. So I went from A to B, so I'm going to go from F to G. Okay, and I just continued along. BC, so I went from single notch to double notch. It's congruent to GH, single notch to double notch. And then AC congruent to FH. On example number 2, we're using the properties of congruent figures, and this time it says that the shape, or the quadrilateral, QRST is congruent to WXYZ, and we're asked to find the value of X. So first thing that I'm going to do is I'm going to say, well, let's see, where is my X? And my X is associated over here with angle W. And since W corresponds with Q, go to my other quadrilateral, and angle Q is 65. So I know that to solve for X, 5X plus 5 is equal to 65. Those angles are corresponding, so they must be congruent since the figures are congruent. And then to solve, subtract over your 5, and then dividing both sides by 5, you get X equals 12. So there's our first answer, that's part A. And then for part B, I'm looking for the value of y. Well, y is associated with the side. We have the side, wx is called y minus x, and this is inches. So since wy corresponds with rq, I'm going to take my y minus x and set it equal to my 6 inches. Now, I do have two variables here, but on part A, I already solved for my x, and I got x equals 12. So if I say x is equal to 12 in my new equation and add the 12 to both sides, I got y is equal to 18. Okay, and next we have what's called the third angles theorem. Third angles theorem says if two angles of one triangle are congruent to two angles of another triangle, then it must be true that the third angles are also congruent. The thing I love about geometry is that it's just so much logic. So I want you to take the definition down of the third angles theorem, and please draw these two little triangles, triangle ABC and triangle DEF, and we're going to add to the triangles, oops, sorry about that, we're going to add to the triangles the fact that since A is congruent to D and B is congruent to E, then it must be true with 3 notches that angle C is congruent to angle F. If two triangles are congruent, if two angles of one triangle are congruent to two angles of another triangle, then the third angles must also be congruent. Okay, and example number 3 says for us to find the measure of angle V. And here is our diagram. We have a 66-degree angle sitting here with a single notch, and we have a single notch over here, so that tells us that that's also 66 degrees. I'm also seeing a set of vertical angles right here, which I know are also congruent. And since they're asking me to find the measure of angle V, which is this angle up here, I'm going to use what I learned earlier about the fact that the angles add up to 180. And I'm going to say 44 plus 66. I'll call angle Vx equals 180. And when I combine these terms, I have 110 plus x equals 180, so x must be 70 degrees. Let's answer the question. Measure angle V equals 70 degrees. And there you go. That is congruent figures.